like a shells. Shall we go for it? Shall we assume it to be made up of a thin shells? Agree this one? Oh, no. So I'll assume again, let me go for. So I'll assume that this particular solid hemisphere is made up of a thin shells. I'll try to give the better diagram. Okay, no, I think, okay, I don't know how the diagram. Okay, this D. And there's a thin shell, which we are supposed to make assumption. Okay, let this distance be X. Or you take any point, will be at a distance X. What is the radius of this? The radius of this is R. Okay, that we know it. The radius of solid hemisphere. So in this solid hemisphere, I'll assume it to be made up of a thin shell, thin hemispherical shell. So what is this? Thin hemispherical shell of radius X and thickness dx. First potential at point O due to this shell. So potential, what is the charge on this? Let it be dq. So dq, how we define? Sigma into the charge on a thin shell. Okay, it's area of a thin shell. Area of a, or volume of a thin shell, will write it. There's a charge of, you write better, charge of thin shell, thin hemispherical shell. No, how much? So this should be, sorry, it should be rho. So what do we get? This will be rho into, what is the volume of this will be 2 pi x square into dx. Dx is a thickness. Huh? Where is the dx? The dx will come here. Able to get this? 2 pi, no, not like 2 by 3 pi arc pi x cube. I'm not asking the volume of the hollow region, the volume of this green color region. It should be equal to surface area into thickness of shell. So what is thickness? Thickness is dx. Surface area is 2 pi x square. I think, hope you are able to understand what I mean to say here. Okay, let's substitute here now. Potential at center due to this thin shell should be equal to k dq by x. K x, what is dq? Rho 2 pi x square dx. So this will become 2 pi k rho x dx. Now what should be the limit? Zero to r, because what is the maximum permitted value of x? X should become equal to 0 to r. So therefore this will become 2 pi k rho r square by 2. 2 pi. What is K? 1 by 4 pi epsilon naught rho r square by 2. Okay, look at this. This is the potential at the center of solid hemisphere. Now, what is dV naught we should call? Potential at the center due to thin shell. So what is the basic idea? We assume that the solid hemisphere is made up of thin hemispherical shells of radius x and thickness dx. Like that, if you add up the layers of increasing the layers of increasing radius, then what happens? We'll get a solid hemisphere. Okay, like this, we'll get the potential at 0.2 at the center of the solid hemisphere. Getting this one? So these are the different types of bodies you'll come across. Again, once again, the primary question: why we should study this potential? Almost for different bodies, I'm showing it like you have to calculate potential like this, potential like this. So finally, what is the use of this? Okay, now the application starts.